Hello, in this video we're going to continue learning about conic sections, and this specific conic section is going to be parabolas. Remember, conic sections are when a plane intersects a double cone. There are 4 different conic sections: circles, ellipses, parabolas, and hyperbolas. So in this lesson we are going to learn about parabolas. Alright, so parabolas occur when a plane intersects a cone through the side and the base. Okay, it has to go through the side and the base. So that plane is going to be going straight up and down. Okay, so parabolas have a vertex, a focus, a directrix, and a latus rectum. Okay, those are 4 different things. You already know about parabolas' vertex. We use those whenever we graph plane parabolas from quadratic functions. The standard form, there are 2 different standard forms. X minus h squared equals 4p times y minus k, or the other standard form is y minus k squared equals 4p times x minus h. So here we notice that only the x is squared or only the y squared, but not both, only one or the other. The vertex is going to be hk, so the number with x is still your h and the number with y is still your k, and the sign is going to change. So if it's a negative in the problem, in the formula, in the function, then your vertex, it will be positive in your vertex. If it is positive in the function or the equation, it's going to be negative when you look at it for your vertex. The distance from the vertex to the focus is going to be p, and your latus rectum is going to be 4p. That's the length, okay? Whenever we get to the point of this lesson where we're graphing, you're going to understand, I will show you what all of these different terms exactly mean, okay? So, let's talk about directions of parabolas. Your directions of your parabolas can face 4 different ways. In the past, they've only been able to face either up or down. But now we can either go left or right, up or down. So now we have 4 different directions. And our equations are going to tell us, are going to indicate which direction our parabola is facing. So if my x is squared and my p is positive, I'm facing up. If my x is squared and my p is negative, I'm facing down. If my y is squared and my p is positive, I'm facing to the right. I'm opening to the right. Whenever I say facing, I mean opening. And if my y is squared and my p is negative, the parabola is opening to the left. Okay, so in this slide, for all of these functions, we're going to identify or determine, is this a parabola or not? And if it is, what direction does it open to? So the first thing is only either my x or my y squared. So looking at function 1, x minus 2 squared equals 8 times y minus 3, I see that my x is squared and that my y is not. Okay, so that allows me to know, and see here I have an 8, that allows me to know that yes, this is indeed a parabola. So now I need to know what direction it's opening. I see that my x is squared and that my p is positive because 8 is positive. I don't know why I'm writing any of this in red. Oh well, it's okay. So when my x is squared and my p is positive, I am opening up. So my parabola is going to look like this. And I don't know about y'all, but whenever I'm working these problems, it really helps me visually. It helps me to grasp what the parabola is looking like if I actually sketch this. So, and we'll see that as we progress through this lesson. Now, my second equation is x plus 12 squared plus y minus 3 squared equals 12. I see that x is squared and that y is squared. So no, this is not a parabola. It's actually a circle because x and y are squared and x and y have the same coefficient and the same sign. It's a positive 1y, a positive 1x. So it's actually a circle. All right, our third equation, y minus 3 squared equals 8 times x minus 2. So I have to ask myself, is only either my x or my y squared? I see that y is squared, and I see that x is not squared. And I have my p out here in the front, so yes, this is indeed a parabola. Now, is it going to open up, down, left, or right? What I notice is that I have a y squared, and that my p is 8. And since my p is positive because it's an 8, I know that this problem is going to open, this parabola is going to open to the right. So it's going to open something like this. Let's look at some more equations and determine if they're parabolas or not, and then determine the direction that they open. Here I have x minus 2 squared equals negative 12 times y plus 2. So R is either only the x or the y squared. I see that my x is squared. I see that my y is not squared. I have my p and everything out here in the front. So this is indeed a parabola. Now, x is squared. My p is negative. My p comes from the negative 12. My p is actually 4 times something. And negative 12 divided by 4 is 3. We'll get into that. I'm getting ahead of myself. So my p is negative. Therefore, I know that this parabola opens down. So I'm going to sketch my parabola to help me visualize which way this parabola is opening. My next equation is y minus 1 squared equals negative 12 times x plus 7. Is only the x or the y squared. I see that y is squared, y minus 1, and I see that x is not. Everything else is in standard form. It matches standard form for parabolas. So yes, this is a parabola. I see that my y is squared and the p is negative because of the negative 12. Therefore, this problem opens to the left. So this parabola is going to look something like this. Now, lastly, we have 2 more problems. What am I talking about lastly? 2x squared plus y squared plus 5x plus 3y equals 22. Are either only my x or my y squared? Well, I see x squared and y squared. So, no, this isn't a parabola. It's also not a circle because I have a 2x squared and a 1y squared. We don't know what this is. We know it's not a parabola. We know it's not a circle. Okay, keep going. In my fourth equation, 2y squared minus 2y minus 4x plus 8 equals 0. Are only my x or only the y squared? I see a y squared and I see an x to the first power. Looking good so far. My y's have the same coefficients. I have a 2 and a 2. And my x has a negative 4, and then I have an 8. Now, what we're going to get into is we have to isolate the variable that is squared with its sister variable. I call it its sister variable because it's y. So this would look like 2y squared minus 2y equals 4x minus 8. Okay? So now, because that will allow us to begin completing the square in a future process. So now I see that my y is squared. I see that I have a positive 4, so my p is going to be positive. Therefore, this problem opens to the right because my y is squared and my p is positive. Okay, in this example, we know that there are parabolas. we need to identify the vertex and the lattice rectum. So our vertex comes from our H and from our K. So our vertex is going to be, remember, if the number is positive in the problem, it's got to be negative in your vertex. If it's negative in the problem, it's got to be positive in your vertex. So since 1 is positive in the problem, it's going to be negative in my vertex. And since -2 is negative in the problem, it's going to be positive in my vertex. And then I need to identify the length of the lattice rectum. Okay, when you see me write stuff out, I will not write out the word lattice rectum. I will write LR. So the length of our lattice rectum is whatever number is right here in the front. In this case, that is 8. Let's go ahead. The directions don't say it, but let's just go ahead and identify our P because that's going to help us in the future. So our P is our lattice rectum divided by 4. So in this case, 8 divided by 4 is 2. So we know that our P is 2. We'll learn how to work with that in just a few more seconds. Now let's look at the second one. X minus 4 squared equals -12 times y plus 3. So let's find our vertex. One thing to be super careful of is to make sure whatever number you're putting in the X spot of your vertex is paired with the X in the problem. So -4 is paired with the X. Since it's negative in the problem, it's going to be positive as my vertex. Whatever goes in the Y spot, make sure it's paired with the Y in the problem. Because sometimes the Y will be over here on the left-hand side, right? So 3 is paired with Y. Since it's positive in the problem, it's going to be negative as my vertex. We can see that the length of our lattice rectum is going to be 12. Okay, 12. Length is never negative. It's going to be 12. So that means that our P, now this negative does tell us something. We'll round back out to that in just a second. Our P is our lattice rectum, which is 12, divided by 4, and 12 divided by 4 is 3. So we know our P is 3. Now our X is squared, and our 4P is negative. Therefore, we know that this opens down. So that negative tells us if we see a negative, we know that our parabola is either opening down or to the left. Okay, that's what that negative is useful for right there. We're still going to identify the vertex and the lattice rectum here. And these two examples are y squared. That's really important to pay attention that you're y squared. Because when we identify our vertex, we have to take a second and go over here to the right-hand side and say x plus 7. Since it's a plus in the problem, it's going to be a minus in our vertex. And then now we see the -1 is paired with y, so it's going to be a +1. Our length of our lattice rectum is 12. Remember, length can never be negative. And our P is our lattice rectum divided by 4. So that's going to be 3. So our P is 3. We also know that this parabola is opening left because my y is being squared and my 4P is negative. My lattice rectum, what's in the front of the X, is negative. Y minus 3 squared equals 8 times X minus 2. Here, my vertex, I have to go to the right-hand side and look to see what is with my X. It's a -2, so for my vertex, it's a +2. And then with my Y, it's -3, so it's going to be a +3. My lattice rectum is going to be 8. Remember, my P is my lattice rectum divided by 4, so my P is 2. And my y squared, my lattice rectum here is positive. My 4P in the function is positive. So I know that this is opening to the right. Okay, here we're going to graph the parabola. This is where everything's going to start wrapping all the way together. We're going to use everything that we're going to find. So the first thing we need to do is we're going to determine, does this function open left, right, up, or down? I noticed that my X is being squared, so now I've narrowed it down to the top 2. And I noticed that my 4P is positive. So that tells me that I match the X minus H squared equals 4P times Y minus K. So I know that this function is opening up. It's going to open up. The next thing we need to do is we need to identify the vertex. So to identify the vertex, the number with my x is 1, so it's a -1 as my vertex. The number with my y is a -3, so it's a +3 as my vertex. My lattice rectum is 8. My p is 8 divided by 4, which is 2. Okay, we're going to see that in just a second, why that p matters. So the first thing we're going to do is we are going to plot our vertex, -1, 3. From here, my focus, okay, it's opening up. This is all going to plot together. My focus is a number that is the distance from my vertex, okay? And it is going to be on the inside of the parabola. The directrix is behind the parabola. The focus is on the inside of the parabola. So because this problem opens up, I know that my focus is going to be 2 spots above my vertex. So I have to go up 1, 2, and that is where my focus is. So my focus is 3 plus 2, right? We added 2 to it. So our focus is -1, 5. Our lattice rectum is 8. So our lattice rectum is the distance across. If you split that in half, I'm going to go 1, 2, 3, 4. It's from my vertex. 1, 2, 3, 4. And then this allows me to graph my parabola. Okay? That's going to allow me to graph my parabola, because here is my lattice rectum. And if I were to count 1, 2, 3, 4, 5, 6, 7, 8. Between those 2 points are 8, and they line up directly with the focus. And remember, the focus is on the inside of the function. And P tells us how far away the focus is from the vertex. Let's do another one. So here we have the function x squared minus 6x plus 2y equals -5. So what we notice here is that this function is not in standard form. So before we can even graph it, we have to get it in standard form. To do that, we must complete the square. Once again, if you are not familiar, if you do not recall completing the square, you need to go watch the video about completing the square. So the first thing I need to do is I need to get my x's over here on the left-hand side by themselves. So I moved my y to the other side. It became a -2y. I'm going to take my 6 and I'm going to half 6. That produces 3. I'm going to square 3, which gives me 9. And I'm going to add 9 to both sides. Half it, square it, add it. So now I have x squared minus 6x plus 9 equals -2y plus 4. Now I need to factor x squared minus 6x plus 9. The two numbers that multiply to give me 9 but add to give me a -6 are x minus, or -3 and -3. So I'm going to have x minus 3 squared equals, and then my GCF in -2y plus 4 is -2, y minus 2. So here, now I can identify my vertex. I can identify which way this opens. Let's go ahead and identify which way this opens. My x is being squared, and I see that my lattice rectum is negative. Therefore, I know that this is going to open down. So I can go ahead and sketch that it's opening down. My vertex, the number paired with my x is -3, so it's 3 as my vertex. The number paired with my y is -2, so it's a +2 as my vertex. I see that my lattice rectum is 2. So my P is -1/2, because I did 2. Let me go ahead and show you that. 2 divided by 4. So it's going to be 1/2. So my focus is going to be on the inside right here. And it's going to be down 1/2. So my focus is 3 and then 2 minus 1/2. So that's going to be 3 3/2 is my focus. Let's graph all this. My vertex is 3, 2. Out 3, up 2. My focus is down 1/2. And my latus rectum has a length of 2. So there's my latus rectum right there. Graphing this parabola, I can see that this parabola is very narrow, especially compared to the previous parabola that we graphed. So that is how you graph a parabola. Being able to identify the vertex and the latus rectum and the P are crucial. If you can't do that, you will never be able to graph. So that is why I spent so much time identifying those and identifying the direction. Being able to identify the focus gets you even farther, and if you have all of those pieces of information, you can transfer them to a graph. So this concludes, finally, the video on parabolas.